Well, welcome back to the bench. So, I hadn't intended on making a series on how to fix a washing machine, and I'm actually not. But I think in the quest to repair our own washing machine, which you can find the make and model of it as a Frigidaire Affinity. I'll put the model in the nomenclature, and chances are if you're listening, it's because you found that model number and you're trying to figure out what's wrong with yours. Well, this is not a please bro solution. I don't know what's wrong with yours. I do know what's wrong with mine, and we'll get to it, and we're going to kind of cover a couple of things. One, what happened, and we'll get to that right now. What happened was it was running. It went into a drain cycle, and it stopped running. So I was not home for that. When I came home, I was informed there was a problem and given orders. I accepted those orders, and during the normal diagnostics, I found that the diagnostic mode, it was giving me a code of E31, which means pressure switch. And they're very, in the manual, it's very matter of fact. If the wiring is good, then change the pressure switch. If that doesn't fix the problem, call the serviceman. Well, I am the serviceman, so that wasn't going to happen. The thing is I went through the switch, and it didn't look like it was malfunctioning. Now, I can't test that the way I'd like. Well, I can. I just haven't set it up. But a pretty common test for that is to just blow in the bottom. There's a small diaphragm. We're not going to get into how that thing really works. It's basically putting out a variable frequency, but due to a circuit board on top. And there could be something wrong with that circuit board, but it's not very likely. So I could check that out, and I may, depending on what we find next. But since it looked, for the most part, it would pass that test, I went to the door switch. It's another common failure with these, although you don't normally get the E31 code with it. And I went through the door switch, and I just made a video about it not long ago and posted it yesterday, so that's a thing. And I went and checked all the normal things that you would check, basically went through the system. Well, down from that switch, which the computer is telling me that, that is where the problem is that pressure switch. It also, it empties into an air bell, and below that air bell is a rubber boot that connects to the bottom of the tub, and there is a coin clean out in there that catches all the stuff that comes out of the drain or of the tub. So I thought, well, I'd probably clean that out. It's probably been a minute. I doubt it's ever been cleaned out before. And well, I made about $2.50. That was nice. And honestly, it wasn't as gross in there as I thought it would be. It's pretty nasty. But moving down into the sump drain, now that is what brings us to where we are at in the sump, which, for those of you who are going to want to know this, the sump is located in the bottom of the washer on the front side, right behind the front panel. So you're going to want to find another video that'll show you how to take that. I'm doing enough with this. I'm sure you can figure it out. So this is the motor, and basically kind of sits in there like this. Kind of just, okay, so I'm not going to clip it all back together, but basically it's going to sit on the bottom, and it kind of looks like, actually I think it's oriented this way when you're looking in there, and this is going to point just a little bit to the back because that boot comes down, and actually it might go this way. I think it clips in the front. Right, because the other boot the black boot comes on and adjusts here, and then there's a different color, like a white boot. This actually is the discharge side, and it goes right out to the hose. Now, I checked this thing out because I figured I might as well make sure that nothing got in here, and when I turned it around to clean it, I found our culprit, and it is right here. See if we can get a camera on it. The bobby pin. Murderer of appliances for over 100 years. One stinking bobby pin was wedged in there. So my theory is the motherboard or the control board is going to sense either whether or not this thing is moving or if it's pulling current, which it was, I'm sure. And it's probably going to not, when this pump doesn't kick on, it's not going to pull the water out of the air bell, which means it's not going to change the pressure. That's not going to see the pressure change it's looking for before it turns on the washer. It's going to say sensing, and it's not going to come out of that sensing mode. And if you go into diagnostics, it's going to tell you to check the pressure switch because it's not seeing the change it wants to see. It's not seeing the change because this isn't turning on. It's on, it's pulling current, but it's not moving because stupid bobby pin or whatever is stuck in here. So I could just go ahead and throw this back in. I've got this thing torn apart. I'm not going to do that. I want to test to make sure that this is going to work. So there's a couple of things, and this is where we're going to get into the next this part of the video of what I'm actually doing right now. You might be able to see there's a light down here on the bench, and that light is a small neon bulb. That neon bulb is essentially sharing a little bit of current with our thermal cutoff, and I will get to what that is in just a moment. The way you would normally test one of these is to come right over here to the windings. Again, if you don't have the ability for this, or you don't think it's something you ought to be doing, please contact a service technician. They will come out and do this. But if you have a multimeter and a little bit of gumption, you can certainly do it yourself. So this is essentially just an electric motor, and this motor has a set of windings on it, and it has an iron core. So their windings are right here. Kind of get that in there. So there's one. And here's the other. Now, if you notice, our terminals, where clips, where their terminals plug in, are down here. That is not connected to this. They're not connected. And the reason why is because they're connected through that cutoff that's down there on the bench. The cutoff sticks in between here, and it's allowing the current to pass as long as the temperature doesn't get too hot. I'll explain why in a little bit. But for right now, in order to test this, I need to kind of take that out of circuit because it's kind of acting like a capacitor. And it's going to throw the measurements off. So once I take that off, I can go ahead and measure from here to here, and I can tell you I get about 15 ohms on this one. So you're going to have to check, see what yours is. But if I have 15 ohms of resistance or impedance across the coils, then this is going to be probably good. These windings are going to be good. The other thing I need to do is make sure that these windings haven't gotten too hot and shorted out against not only themselves, but that's what we're checking the resistance value for, but I also want to make sure that they're not touching or shorting out to the core. Okay, so I would need to take the meter and go from the connector over here, and if I don't have any continuity, if I have an open circuit, we're good. If we have a closed circuit, this thing's no good and it's going to have to be replaced. So I know that the motor spins, and I've already checked it. I know I've got about 15 ohms. I don't have any continuity between the iron and the coil, so it's probably good. The last thing I need to check is, for the rest of you nerds that are like me and like to know how things work, is the thermal cutoff, i.e. here. Not to be confused with an NTC or a PTC thermistor. This is actually a bimetal cutoff. So bimetal cutoffs are used in a lot of things. I work on refrigeration decks. They use those as overload protectors. In the start, for the start windings on compressors. So in this case, they're basically using it to test the temperature to make sure if the coil starts to get hot on this pump, it will kick out the power and protect it, and it looks like it probably did its job. So what I do want to do is make sure that it's not bad. So the way that we're testing it is, I've got this bulb set up, and we actually have 100 volts. 60. We're basically doing a little bit of voltage sharing here, so it's looking low. But we've got the transformer, the isolation transformer, and auto transformer is set up for about 100 volts. So we've got a set of probes across this. Our light is on, and then our cutoff is in series with our light. So the voltage is passing through our cutoff, through our neon light, and actually through a resistor to kind of drop the voltage, i.e. the voltage sharing. We're dropping the voltage because this is only rated for about 117 volts. So if we try to put 120 volts through it, it would pop. Of course, I can control that with the auto transformer, but I don't want to take the chance of turning it out too high or but when popping the neon bulb. So we're just doing it the right way. We've got a dropper resistor essentially, and then we've got our cutoff in the back. So what I'm going to do is kind of show you how it works in theory. The theory behind it is this cutoff, this little circuit that we set up, Meter's telling me it's time to stop. This little circuit is basically mimicking our coil. Now this is not an inductive load. This is a neon bulb, not an incandescent. But this, it's going to mimic our load for our demonstration, which is essentially that this cutoff is allowing voltage to pass through it. But once it reaches a certain temperature, it will no longer allow that voltage to get through. It's a bimetal disc, which is the two bimetal discs, which means they will get to a certain temperature and they will separate. And these are set up to separate at round about 165 degrees Celsius. So what we're going to do is, and this is going to get loud and my shop lights flicker whenever I use it, I'm going to use this heat gun over here. I'm going to turn it on, and as this thing starts to get up to about 165 degrees Celsius, it's going to cut off the power. It's going to separate those metal discs and cut off the power to our light. So just be advised, I'm not going to be doing any editing to cut sound, so you're going to hear it. Can't do anything about it. And here we go. And I'm sure the flicker is probably horrible on the camera. Maybe it's not coming through at all. Right in here. I'm just going to start hitting it with the heat, and you'll see that light will go out. You should hear a little click. Any day now. Well, should be getting close. Kind of keeping it moving because I don't want all the heat going in the same spot. There it goes. So, now the power has been disconnected. The thermal cutoff did its job. I don't know exactly what temperature, but I know it was probably getting close to its cutoff temp. And if we sit here and watch it, since we still have voltage, what should happen is that the metal will cool and those discs will pop back out and make contact again, and we will have voltage flow. So, we want to talk about maybe some weather. Well, we didn't have to do that very long. There's our light. So the light is back on, and you can see now our voltage has come back up. So that, in a nutshell, is how a thermal cutoff works. And again, we have them in all kinds of devices. They're not the same as an NTC or a PTC. So an NTC what is an NPC? Well, let's see. There's two different types. There's the NPC and PTC. I say NP. I said NT. Yeah, NPC. I think we all know what those are. Let's see. Right, negative temperature coefficient. That's what that is. Or a PTC, which is a positive temperature coefficient. So, I guess if you're really, I did make a little diagram. The thermal cutout, if you ever need to see it, this is what a thermal cutout looks like. So this is basically what our it's just a little simple circuit. This is our coil. We have one side of the winding here. It goes through the coil. It comes out. It goes through our thermal cutout, and then it goes back out the other side. So essentially, if we tried to read our resistance across the coil, this is going to throw it off. So we'd have to come over to the other side of it, which we definitely could do. All you need to do is lift a leg off of this. But since I wanted to know what it was in there and if it was damaged, I needed to go ahead and take it out. So, and I figured, well, since I've already got it out, I'd go ahead and set this up. So this is for the nerds that like to learn. So I'm not going to really go into any more on this. I'm going to go ahead and put this back together. I will say this was not welded or soldered into place. It was just pinched, and that's exactly what I'm going to do. I just carefully took a pair of snips and I kind of bent the tabs up just a little bit, pulled the legs out, and then slid it out. And then now that I've tested it, I know that it's working. I'll go ahead and put it back in, and I'll pinch those legs right back together again very carefully, because these tabs get brittle, and I might even warm them up just a little bit just to kind of anneal them a little. So essentially, I think that motor is going to work. I think now we've got our bobby pin put together. And I'm putting a little disclaimer that we're not going to show an actual working washing machine. I don't think anybody cares. I certainly don't. I have other things I'd need to get done. So That is our demonstration. I think that I've covered everything I wanted to mention. If you have any questions or comments, please put them in the bottom. If you have other issues related that you might think other people might want to know about, by all means, please leave them there. I don't know that I'll be back. I'm not really a washer dryer technician, so if you have specific questions, I don't know. I'm just a dude that's fixing a washing machine that's in my utility room. That's it. I'm not an expert on this stuff. But everything that I've looked for, I've tested for faults, and at this point I've kind of eliminated all of them. So if I haven't fixed it at this point, I will probably put a new a pressure switch in, and I might make a video on how those work again, because they're actually pretty cool. We talked about the thermistor, we talked about the resistance, and that is pretty much it. So yeah, I mentioned everything that I jotted down on my little notepad. So if you're going to work with this stuff, you're working on your own equipment, please, again, be careful. It's dangerous. There was just an incident where not where I work. I work out in the field. I go to all kinds of places. I was at a place where someone had touched a machine. There was water on it, and they got zapped and wound up in the hospital with some kidney issues. So electricity, and that was 110, the same thing that you have in your house. So if you play around with this stuff, you're doing so at your own risk. It's very dangerous. If you don't understand how electricity works, please don't mess with it. If you're not confident in your abilities, leave it alone. I set this up so that you can kind of see what happens. If you're gonna work on it, disconnect the power from the machine. I'm on a bench. I've taken precautions to make sure that even if I do something dumb like this rat's nest you see, and I touch a couple of things together, the worst it's going to do is light up a couple of bulbs at the end of the bench. You don't have that coming out of your wall. So please, please be careful. Please use your brain. Do not mimic the monkey. Okay, you guys have a wonderful day. We'll see you in the next video.